Hello and welcome back. What I'm going to look at is, this whole video will be on velocity. So it's more or less page 349 in your textbook. Right? Please not just right there for some strange reason. Right? Page 349 in your textbook. We're going to look at velocity, and the thing that I want to make clear about velocity is very similar to speed, but it is different. So we'll start off and we'll just ponder our way through the whole thing, and we're going to talk about velocity. And the important thing about velocity is that it's a vector. And what's important about a vector is that it's got two components. We've talked about this before. Again, sometimes you have to go over stuff again. So it's got two components. Size. And that's the speed bit of it. The size bit of it. And pen's doing doolally today. Right? So size. Try that again. So don't do it. Oh well. So we've talked about the size. Like, it could be in meters per second. Right? That could be your speed. Remember, that's the same as written as meters seconds to the power of -1. They're all the same thing. It could be kilometers per hour, it could be centimeters per year, depends what you're talking about. But the thing that makes velocity different is it has a direction. Speed has no direction. And when you think of direction, well, we're more or less going to talk about up and down. Usually, up's taken as positive and down's taken as negative, but that doesn't mean anything. Right and left, usually, left is negative and right is positive. But you can, as we sit here today, and I'm doing this, nothing is usual. And then you can also have naughty, elephants, squirt, water. You can have that as you wish. But it has to have a direction, right? And you have to have a zero reference point. And that's what's important. You have to refer to somewhere. So I'm going to go up here. Hopefully the machine will follow that. And here is a great snap of you in the scratcher pit. There you are. That's you in bed. And normally you will get back into the same bed you get out of. Normally, unless you're on holidays or going visiting or something. So what I want you to think of whenever you get out of the scratcher pit and back into the scratcher pit is to think, at the end of the day, if you get into the same bed you get out of, you have travelled zero displacement if you take that as your reference point. But that doesn't mean to say that you haven't travelled a distance. So saying, for example, in a day, you travel a distance of, we'll say, 126 kilometres, right? And you're up for 14 hours. Some of you need the beauty sleep. I don't. Well, let's have a look at this. I better write that in his bed. Somebody's might know where it is. So, saying we look at the speed of this person. Well, we know that speed is distance over time. So how far did they travel? 126 kilometres per 14 hours, which gives me 126 divided by 14 gives me 9. That units in kilometres, that units in hours, so it's kilometres per hour. So their average speed for the day was 9 kilometres per hour. Now that doesn't mean to say they travelled 9 kilometres per hour. Some hours they did, some hours they didn't. Some they travelled more, some they travelled less. But that was the speed. But let's have a look, go back up to the old scratcher pit here. And let's talk about the velocity. And the velocity is your change in displacement. Velocity equals displacement over time. And if you started in the scratcher pit and you came back to the scratcher pit and that was your zero reference, that means your displacement is zero. and it took you 14 hours. Nothing divided by 14 is still nothing. So your average, your velocity is nothing. And your speed is 9 kilometers per hour. So they are very, very similar, but they are totally different. So I want you also to think of velocity as change in displacement over time. Change in displacement over time taken. And this is a very important concept. Like, of all the important concepts I probably do on this page, this is probably the most important one. Do you see that word change there? Hold on, I have it over time there. You see that word change? That is such an important word, because change means the end value take away the start value. It means the end minus the start. See why I'm talking to myself again? Well, in this case, nothing new there. So that's what change means. It's the end value take away the start value. And that's your change. And that is such an important concept in physics. Because change means your end take away the start. Now, if I go back up here again, please machine follow me up. I could say that change in displacement means the displacement at the end take away the displacement at the start divided by the time taken. That's what velocity means. Now, we'll go down here, we'll finish off this, and we'll talk about, here's this young chap, and he or she is running, but they're happy, right? They're happy. He or she is running to the right at a speed of 2 meters per second. They have a speed of 2 meters per second, but they have a velocity of plus 2 meters per second, because I have decided that that way is plus. Fair enough? Whereas, same young chap, right, also happy, they're going to the left with a speed of 2 meters per second. So every second they cover 2 meters. But they're going to the left. Oh, he's not happy. No, he's happy now. So their velocity is minus 2 meters per second. So they may have the same speed, but their directions are different. This chap's going towards the right, so their velocity is plus 2 meters per second. They have a speed of 2 meters per second. This chap is going to the left, so they have a velocity of minus 2 meters per second and a speed of 2 meters per second. The direction is important. And finally, I don't know where you're going to use this. Average velocity. How do you find the average of a thing? You add them up and divide by 2 if there's only two things. Initial velocity plus the final velocity over the time taken. So there's a little amble through velocity. Have a look at that. Read page 349, see does that happen. Because the next thing I hope to do is I hope to do Newton's second law and acceleration. Thanks for listening. Bye.